Hey everyone, thanks for joining us today. Today's webinar is co-hosted by NYOUG, that's the New York Oracle User Group, and Viscosity North America, Oracle Platinum Partner. My name is Monica Lee, and I'm the Marketing Director for Viscosity. We are a full Oracle Stack consulting firm with core expertise in Oracle database, and that includes RAC, Apex, zero downtime migrations, performance tuning, high availability, you name it. We've also got decades of experience with infrastructure, including engineered systems. During today's presentation, feel free to submit questions to our presenter, Craig, in the questions and chat prompt should be seen on the lower right-hand side of your screen in GoToWebinar. So, today's presenter, Craig, will get to your questions as soon as he sees them. So be patient, if he doesn't get to it right away, but he's going to do his best to try to address it as soon as possible. So representing NYOUG, today I have Coleman Leviter. Coleman will introduce to you a little bit about NYOUG and also to the speaker.
Thank you, Monica. So NYOUG has been formed in 1984 for exchange of ideas and assistance with a lot of the Oracle products. You can connect with us on Twitter, Meetup, LinkedIn, Facebook, where our website is nyoug.org. Of course, we outreach to our members at the Oracle Community Board at community.oracle.com, Community User Group. And of course, we want to thank Viscosity North America for co-hosting the series of webinars with NYOUG. Now a little bit about Craig Schallehammer. Craig is president and founder of AuraPub. As you can see by the hat, that's the official AuraPub hat. And he has over 30 years of experience in consulting, training, and tool development in analytics, which is machine learning, and Oracle database performance tuning for hundreds of companies around the world, including Oracle Corp. Craig holds a Bachelor of Science in Economics from California Polytech State and San Luis Obispo, and is an Oracle ACE Director. And again, I want to thank Viscosity and Craig for doing this series today. And Monica, let me hand it over to you.
Thank you so much, Coleman. And again, don't forget to take advantage of the time you've got with Craig. Send him questions throughout. I am going to follow up with all of you afterwards and give you any useful links that he brings up today or any other information like that. So otherwise, take it away. It's all yours, Craig.
All right. You can hear me okay and see me? We're all good?
Looks good.
All right.
Perfect.
Perfect. All right. Hey, thank you all. Coleman, thanks for wearing the hat. There's very few of those in existence. So yeah, today I get to talk about machine learning, and we're going to talk about one of the key use cases for machine learning, which is anomaly detection, specifically about like strange things that are going on in the database. So that's going to be the application. But you're going to be able to actually download this notebook that I use that I'm going to walk you through pretty quickly, and then you'll be able to like essentially do everything that I'm going to show you how to do. So this is, and it'll be recorded, so you could actually watch me step by step as I go through it, and then you could actually do the same kind of thing. All right, so this can be about half demo with that notebook, and then half just like introduction to machine learning, that kind of stuff. So if you got any questions, like Monica said, go ahead and just, I don't know, type them in there, and then I'll try and get to them. I mean, I'll see them on my screen, and then at a good little break point, pause point, I'll address those as soon as I can. All right. Oh, the beard. Yeah, if you haven't seen the beard, this is my COVID beard. I haven't shaved it anything since mid-February. So, but it's really getting out of hand. And next time you see me, it's probably going to look very different. So it's starting to scare children at this point. So I got to do something. Either that, or they look at me like it's Santa Claus. We got both of those going on. So with that, all right, so Oracle performance issues. So this is targeted toward people like me, maybe like you, Oracle DBAs and developers. So when we have performance issues, they typically fall into two categories. And if you think about your experiences, Like, let's say you're looking at an AWR report. If you look at it, you're going to say, oh, I've seen this before, and it's really bad. Right? That's one common response. In fact, it's kind of nice when we recognize a problem, because we have some experience, we have an experience base for that. The other situation is you look at the AWR report or whatever you happen to be looking at, and you say, I've never seen this situation, so we better check it out. So it's not necessarily bad or good, it's just that it's unusual and we've never seen it before. Okay, so those are kind of two broad areas. So the good news to that with that is that if you're good at AWR and Ash analysis, you're going to be able just to rock and roll, and then you're going to be able to do a great job. And on either one of those situations, you'll eventually figure it out and come up with some really good solutions. But there is bad news, right? The bad news is this does not scale. It doesn't scale, and that's because it's based on a person, you and me, and we physically, we haven't figured out how to scale this yet. And even if you're super good at this, as the number of databases and systems that you're supposed to monitor and take care of, as that gets larger and larger, which it always seems to do, you physically just can't do that. And so the quality is gonna significantly drop. And if you've worked closely and tried to work with rule-based systems, like if this happens and this happens, or this happens, boom, trigger an alert, it's really uncomfortable, because if you want a really good alerting system, you're going to start to dial it down, but then you got a lot of false positives. Is that false positive? Yeah. And that's bad. So then you loosen it up and then you miss real performance problems. So rule-based systems, they don't scale either. And there is a better solutions. One of the solutions is that we can actually use machine learning to do this. And machine learning, when I started with those two different kind of categories, is there's applications in both of those for Oracle systems. And what I'm going to focus on today is anomaly detection. Okay, like some really bizarre event happens, and we actually want to start working on that and figure out what's going on before like the phone starts to ring. All right, and so that's what we're going to focus on today. Now, I want to add this though, because when we talk about performance, Oracle performance, usually there's an assumption that performance is bad, right? People are not happy; they're screaming, literally screaming. I've seen guys like physically assault another guy before. Good times. But for anomalous performance, what the machine learning is going to do, it's basically looking for something that is highly unusual. And it can be unusually good performance or unusually bad performance. It's just unusual. So keep that in mind. So usually what we do when we implement something like this that detects anomalies, we will add some rules to kind of filter out the unusually good performance situations. Okay, so keep that in mind. All right, real quick intro about me. I'm a longtime Oracle DBA, and my whole career has been about performance tuning, predictive analytics, capacity planning, all that kind of stuff. And now we got machine learning, which just kind of adds to that. And like one of my books is Forecasting Oracle Performance. That's like, before machine learning was machine learning, that's what we had to do. And so I have that base of forecasting and thinking about this kind of stuff. And then when machine learning became available, and I'll talk more about that, to the masses, then all of a sudden it's like, boom, we got something that I love doing now we can actually do at a higher level, and businesses are starting to embrace this now. IT kind of, not so much, which is really a bummer. So I got a blog. I do a lot of experiments and I put those on my blog. Author of a couple books, do a lot of conference speaking. It's kind of been nice actually not traveling so much this year, although I really miss the personal connections. I do a lot of teaching and mentoring. I have some LVCs, live virtual training. In fact, this afternoon, I have a first session of my machine learning LVC. Coincidentally, it's kind of strange. And the first thing we start with is is anomaly detection, since that is one of the easiest ways to start learning about machine learning. So I'm an Oracle ACE director. I've also been like a DBA track manager for a bunch of years for the NYOUG conference, which is now like, Quest, not Quest the software company, right? Quest, the user group. Yeah, really unfortunate name. So AuraPub is a company, that's my company, and I serve Oracle DBAs and developers. And really the people that I really work with, they're serious about performance or machine learning, and they want to take it to the next level. And so the whole website, the whole company is all about empowering DBAs and developers to go to that next level. And there's tons of free stuff on the website. I mean, tons of stuff. But all the really primo content, I say for my members. And we have a membership program that's, there's free membership, but there's also the paid membership. That's the primo stuff, monthly, annually, all that kind of stuff. Okay. And you get discounts on my OVCs and all sorts of stuff like that. We got a forum on Slack, stuff like that. All right, so check that out, okay? The last thing I wanted to mention here is that what I did is I created like a self-paced 18 sections that sound right, 18 lesson, I don't know, there's 18 lessons in this thing, and it's self-paced. It's super simple and easy to go through, but the whole idea with this was for DBAs to at least start going through this, and then you will know if you're interested in machine learning or not. So it's a really low entry, low stress way to say, yeah, I wonder what this stuff is like. So if you're interested and you're just kind of curious, then just go to this URL, it's aurapub.com, www, and then /ml-ecourse, and boom, you'll get the, you sign up and you get the first one. So it's a self-paced kind of thing, 18 lessons. Super cool, I'm really proud of it. Hundreds and hundreds and hundreds of people have gone through it and they love it. All right, so you can, this presentation I've given before, but I update it all the time. So I'm sure I'm gonna present it again at another time, and you can always get the latest on my website. You just go to AuraPub, and you log in, so you have to be at least a free member, so I know your email, so I know who you are, and you just navigate the tools and presentations, and then boom, you'll see it. Okay, so my machine learning journey, real quick, because we're going to run out of time here. I started, it's like many of you might have been doing this kind of thing. I actually created a Tic Tac Toe program to play itself, and it got better until it always tied. And I could also play it once it learned. And once I saw it kind of playing itself and getting better, I was like, wow, this is really cool. But somehow I got in the Oracle world, and we really didn't do that kind of stuff. But I was working for Oracle at the time when I did that. One of the first things I started working with is neural networks. And I actually did a session at the Rocky Mountain Oracle user group years ago on neural networks, but it just didn't take off. So I was really disappointed. So a lot of this forecasting type work was eventually ended up in my forecasting Oracle performance book. I don't talk about neural networks in there because I was never able to actually get something useful to happen with neural networks at that time in Oracle systems. It was just too far out there for people to even really conceive. But man, it was a lot of fun. So with that, once we got into this machine learning, we started hearing about it, and I'm like, is this for real? Is this really gonna go? Because I was like, man, I really hope so. Because when I first joined Oracle in '89, it was a totally different world back then, right? I mean, people like managers, they'd kind of whisper to each other, and they'd say, hey, have you heard about relational technology? It's important. Okay, that's what they were saying back then, right? Nobody says that anymore, right? So our jobs for super sexy and super cool are like nothing. But now it's changed, and now they're saying, hey, have you heard about AI and machine learning? You need to check it out. And so it's turned my DBA job, which I love the performance solving the problems, but it's added a whole nother dimension to it. And now there's actually a pull for this instead of me pushing, which is really, really nice when you've been doing this for a bunch of years. All right, so what is machine learning? Okay, before we start messing with it, let's figure out like how it all fits. First of all, it's a part of AI, and people talk about it. They call it AI, or they call it AI machine learning. Machine learning is just one of the kind of pillars underneath AI. So that's one of the first things you need to know about. But machine learning in particular, it really is it's all about patterns. All about patterns, which we as people are really good at patterns. But man, machine learning is like patterns on steroids. I mean, it's just like crazy powerful what we can do with that in terms of patterns. So it's about extracting interesting, right, and useful patterns, things that we can actually use. And this is done, there's actually a method we go through to do this. There's a lot of options to the methodology, but you'll notice any machine learning product will follow a certain flow, especially in terms of developing the actual models. Okay, there is a wide variety of algorithms. So this is one of the things that really, when that started to happen, that is when this whole, you know, analytics and capacity planning, performance predictions just took like a hard left turn and just went boom. It just started rolling really, really fast. There's a number of, I mean, there's probably hundreds out there. And but what we're going to focus on, clustering today. We're going to do a one cluster model, and it's going to be centroid based clustering. So that's the model that we're actually going to use today. Super cool. I think you're going to love it. I hope you do. All right. So now the other thing that machine learning has, besides the algorithms, it has all these super cool computing techniques. I'll say actually statistical and computing techniques that are actually built in to the machine learning libraries, whether you're using Python, whether you're using R, whether you're using like Oracle machine learning and just SQL, PL SQL. Most of the techniques are actually built in. It's super cool. And stuff that I used to have to do manually in an Excel spreadsheet are now just like a one-liner. Or that one-liner goes way beyond what I could do before or what I even thought about doing before. That's why I'm so excited about this, because it's just like, oh man, what a great idea. Like, who thought of that? You know, stuff like that. So we're not going to talk about all these, but these are the things that I talk about when I do machine learning, and then in my LVC. Am I pushing my LVC too hard? No, hopefully not. All right, but what's changed? What's the big deal? Like, why the buzz right now? Well, there's actually there's a few really, really good reasons. Okay. All right, I just saw something flash. I want to make sure everything's good. Oh, by the way, there's a raging storm outside. So if I do lose power, I'll try for about 10 minutes. Okay, I'll just tell you that. All right, so why the buzz? Management, like I said before, they're like, hey, have you heard about machine learning? Have you heard about AI? Totally, I love it, love it, love it, love it. Okay, the other thing is software. Okay, it's incredibly powerful and it's 100% free. 100% free. Okay, it works on any platform, Windows, Mac OS, works on Linux. You know, it's there for you. Okay, so the main platforms, there's a bunch of libraries on Python and then R, the free statistical package. These are the main ones people actually use. Okay, but Python more than R. Now, people are going to argue about this, but my experience based and talking to people who actually do, like data scientist people, I don't consider myself a data scientist. I'm not trained like that. I'm like a practitioner. Okay, and I learn what I need to know to do my job. It's always been like that. R seems to be more academic. Python is more industry. Now, I'm sure the rules that blurs a lot, but I do know that even Oracle Corporation is moving kind of away from R and more Python in terms of machine learning. It's kind of like Linux or Solaris. Oracle's good with either one, so it's just going to go wherever the wind blows, and the wind is blowing to Python. So what I did after I started doing machine learning in R, and I heard that, I'm like, ah, crap, now I got to learn Python, you know? So I've been working on Python, and it rocks, man. Python is so cool. I love it. It's much more of a computer language, like a language like I'm used to writing stuff in, than R is. And so I'm really stoked on Python. So that's what I use in all my machine learning classes. And when I actually do this for consulting and for people, I use Python for all this stuff and for my own personal work. Okay, what about Oracle machine learning? Okay, the Oracle has a really good argument for machine learning, and you won't know this until you actually start really thinking about this. See, machine learning needs data. Now, our applications, we don't need as much data for the stuff that we do as a DBAs. But when you get outside of Oracle performance, like alerting and monitoring, and you're actually looking at shopping cart analysis and all the traditional machine learning applications, what's going to happen is you're going to have, there's just like tons and tons and tons of data. And so Oracle's argument is, hey, don't move the data to like another machine to do the number crunching. The data is probably already in Oracle. So let's move the math, let's move the algorithms into the database, and we can just start doing the crunching right there. That sounds really good. And it is good, but if you're a trained Oracle DBAs, you probably thought, well, wait a second. That takes a lot of processing to do machine learning. So you're gonna like load that on my production box? Yeah, that's the idea. So you got to deal with that, okay? If that's the way you want to do it. For my type of work that I do with the amount of data that I do, you can do this stuff on a small Linux box, okay? And I actually don't need Oracle machine learning, okay? From a industry perspective, it's Python or it's Google, okay? It's you know, actually I don't want to go down that path, but it's really not Oracle right now, but they're trying and they're working hard to do that. Okay, so that's all I want to say about that. Oh, it's really cool that this stuff is in SQL. In fact, I want to add this: if you're gonna, if you have an existing Oracle-based application and you want to just add some machine learning like into the application for, I don't know, for whatever recommendations or just for whatever. If you wanted to do that, it's a pretty good argument also to use Oracle's machine learning, because the data is right there. It's probably written like in PL SQL, and so it just makes sense to do it in Oracle right then, instead of doing it in Python, calling an external program, and all that kind of stuff. So that's a really good argument also. I need to put that in the slides. Okay, the other thing is computing power. We got tons of computing power, and you know. Python, and I'm sure Oracle does too, because it's parallel, they can make use of multiple cores. So stuff rocking, where you want to saturate your machine, no problem doing that. Lots of data, organizational impact. It's way more than just finance, you know, quantitative trading and stuff like that. Okay, this is important. Okay, I know I've been monologuing here for a minute, a couple of minutes. Okay, domain expertise. This is really, really important. Okay, how does this relate to me as an Oracle professional? Okay, let's say we're doing a machine learning project and it's about detecting, it's like early detection of cancers in like an x-ray. Okay, so I have this x-ray right here, and I look at this and I say, yeah, that's cancer right there. Okay, so if my task is to develop an early detection machine learning system to detect cancer, doesn't it make sense to actually have somebody on the team who actually knows how to do that in real life? And you'd say, well, of course, you'd be like an idiot not to have a guy like that on your team. You'd be like complete idiot. Well, if we're going to do a system that has to do with an Oracle system, and specifically if it has to do with Oracle performance monitoring and alerting, wouldn't it make sense to have an Oracle DBA on that team? Yes, it would. Because we know what an active session is, right? We know what average active sessions is. We know what the SGA is. We know all that stuff. And so we're like, we have domain expertise. And so use that to your advantage. So if you're a DBA or developer and you actually want to get into machine learning, remember you are valuable when you leverage your existing knowledge with machine learning. Don't go to the data scientist people and say, hey, I want to do what you do. So, no. You say, listen, I'm an Oracle expert. I've been doing this for years. Let's use machine learning with Oracle, and I can help you do that as a domain expertise. Your argument is much stronger, believe me. All right, so you have that domain expertise, use it. Okay, so let's actually do some machine learning here. Okay, we're getting close to the demo here. Just have a few more slides, and then we're gonna, okay, I need an extra 10 minutes. Okay, I'm gonna tell you right now, I've been, oh yeah, that's because Coleman and Monica, that's because you guys stole like 5 minutes of my time there. Okay, so machine learning. Okay, I've seen, remember those two case studies or use cases? I've seen this before. So it's like you look at all the fish and you recognize a pattern. Machine learning says, hey, I've seen that pattern before. Okay, and we call that classification. So it's a classification problem. Another situation is you look at the fish and you say, huh, that's a red fish. That's unusual. I haven't seen that before. Okay, that's the anomaly detection. And this is what we're going to focus on today. Okay, now one of the first things you need to understand is there's because people will just throw out these terms all the time. By the way, that's the hardest thing for DBAs to learn machine learning, is that there's a whole new vocabulary. And some of the words that we're used to saying or talk about, like a column in a table, no. It's now called a feature in a data frame. Oh yeah, so you got to deal with stuff like that. All right, but you need to know about the differences between supervised and unsupervised learning. So I got a couple of slides to help make that so we can actually learn about that really quickly. So we have machine learning, okay, under the umbrella of AI. We have supervised learning and unsupervised, okay. So supervised learning is when, like, we know the answer. We know the answer. So let me jump to the next slide real quick. Here's a supervised learning example where I have for like an AWR snap, I have all these statistics right here in this one row for this one snap ID. I could have hundreds, I could have thousands, but I also have what's called a label, and we are labeling that performance as bad or good or green, yellow, red, whatever we want to call it. But it is usually it's a discrete set of values like bad or good or green, yellow, red. Okay, and there is a difference. If it's a discrete set of answers, the labels here, then that is going to fall into a classification problem. If it's not a discrete, if it's like 1.25 or 3.24, then that would fall under the supervised learning regression problem, which is, in fact, I don't even teach regression stuff anymore. If somebody asked me, I said, no, I'm not going to do that, because the future for us is not regression. Okay, it's the classification, that piece of it. Okay, so now this is super important. I talk about this a lot in my LVC, because is performance good or bad? Okay, we get the label outside of Oracle. See, as DBAs, what we want to do, we want to do some math to derive whether it's good or bad. Wrong. Okay, wrong. If you do that, we do not need machine learning. That's what our rule-based systems already do, and they suck at that. Okay, so what we need to do, we need to get the user experience, for example. And so the classic example I use is the number of tickets per hour. And that's a really good way to know, was performance really good or not? You know it's bad if you get a jump in support tickets. And so what we're doing, we're looking at like Oracle activity and support ticket activity, and we put those together. Okay, so there's a lot I can say about that, because as DBAs, this is the hardest thing in the world to do in supervised learning, is to come up with the label. It's sometimes called the target, because we want to create a formula. Don't do that. You're just like, you're negating the whole work. Now, unsupervised learning is this right here, and one of the algorithms is called clustering right there. So unsupervised learning, like, we don't know the answer. We're actually just looking at the data and we're saying, like, that's an interesting pattern. Maybe I could use that. I know it's really woo-woo and it's really difficult for us to understand that. But the anomaly detection kind of brings like a use case out for us in this. I mean, I actually use unsupervised learning a lot personally. That's how I determine who to send some of my emails to, really some of my marketing emails for certain things. I actually wrote a machine learning system to say, like, these people are more likely to be interested in this, and they're the only ones who get the email. It's good. That way people don't get bombarded with so many emails. So that's an application of unsupervised learning. So for example, so you have all the data, we have the same data as up here, but we're not trying to figure out whether it's good or bad. We just want to say, hey, this snap that just happened, is that unusual? Does it look like any of the other snaps? Because if we haven't seen something like this, then maybe we should check it out. And that's like anomaly detection right there. Okay, and so we don't need to know whether it's good or bad. Let the machine learning, look at all the data up here and kind of just do some math on that, let's say. And then we'll look at some new information and say, does this kind of fit within what we've already seen before? That's like anomaly detection at the core right there. Okay, so how do we actually do this anomaly detection? Okay, so I'm going to show you the strategy we're going to use, and then I'm actually going to demonstrate that, and then you can do the same thing, which I hope you do, because it's super cool when you actually press the button yourself. And by the way, don't let Python stop you, because if you can know PL SQL, you're gonna, or anything else, you're gonna get Python. All right, it's actually easier, I think. Okay, so we're gonna do unsupervised learning with one cluster. Okay, so we're looking for like this red fish, like, that's really unusual. Okay, all right, so here we go. By the way, there's a number of ways to do this. There's many different algorithms we could use, all sorts of stuff we could do. Okay, this is how we're gonna do it. Okay, so what we're gonna do, we're gonna take all of the data we have, and we're gonna tell the machine learning to create a cluster. So just think of like a galaxy or universe, or a galaxy, something like that, and you got all these stars, right? Okay, so we're gonna actually, it's gonna create a cluster. Okay, now this might not look like a cluster, but that's because we've actually reduced the dimensionality, which I'm going to talk about, into 2 dimensions, so we could actually plot this thing. So we needed an X and a Y. So in reality, it's a cluster, but it looks kind of wacky right now, but that's because we need to understand that. And so we need 2 or 3 dimensions to do that. So we're going to create a one class cluster. So basically it's just one cluster. Okay, that's the first thing we're going to do. Okay, we're gonna have machine learning is gonna do that for us. Boom, just like that. It's so fast. The next thing we're gonna do, we're gonna create a threshold. All right, we're gonna create this threshold. And so anything outside of this threshold will be deemed anomalous. And so the threshold is, we're gonna create a super simple, but hey, don't discount simplicity. Okay, it's super, you'd be surprised how good this works. So we're going to set a threshold right here. Okay, now all of these points are now deemed anomalous, but we don't care about all the other points. All we care about is the most recent snap, right? The snap happened, we go through this process, we create the cluster, we create the threshold, and then we say, where is the most recent snap in the cluster? If it's in here, we've seen it before, not a problem. But what if that's the most recent snap? Or what if this is the most recent snap, that point? Well, then that would be deemed anomalous. Bing, 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 we start alerting. And so we're gonna say, where is the most recent AWR snap? That's it right there. It's beyond the threshold, therefore it's anomalous, alert. Okay, so you can see how this can scale, right? Now, instead of having all these screens or waiting for something to flash, right, that based on rules, which is just get all sorts of weird flashes and all the stuff we talked about, machine learning can actually do this for us, and it can actually look at hundreds and thousands of systems. Super cool, huh? All right, so let's actually do this. Okay, so to do this, I'm going to use what's called a notebook. Okay, I haven't got any questions yet. You guys still there, and everybody good? I've just been monologuing away. I'm hoping you could hear me and all that kind of stuff. I'm on airplane mode, So, oh, I still will get a text though, Monica, if I'm not online. Okay, so this is called a notebook, and I'm using what's called a Jupyter notebook. Okay, now this is from an industry perspective. This is the industry standard right now. That's why I'm using this thing. It works better than text files, than developing the Python code in a text file. It's really good for learning, great for development. When I actually deploy this stuff, I actually just do like a file and then download as, and I just get text or Python right there. Boom. Okay, so all this stuff here would just be commented out then. That kind of thing. All right, so yeah, notebooks rock. They're super cool. You'll see this all the time in demos. Okay, so the way notebooks work is you have all these cells, and then you evaluate the cell. So instead of running the whole program, you just run a piece of it. So that's why it's so good for development. Okay, so the way I wrote this little quick anomaly detection, almost you basically go through this thing top down. Okay, I'm going to have a bunch of functions I'm going to create, Python functions, and then at the very bottom, we're going to have the main program, which will then call the functions. So what I'm going to do is I'm going to go down to the bottom. I'm glad I started talking about that. You see all these, some of these functions I'm going to talk about. Some of them I'm just going to say, check them out if you want to. Okay, down here at the bottom, this is the main program, and the main program is really short. That's it. Right here. I mean, it's super simple. There's a lot of space there. Okay. So, but you'll notice that we have the 4 steps. First thing we're going to do, we're going to build a cluster. Second thing, we're going to determine the anomaly distance threshold. So we know if the point is like way out there, boom, that kind of thing. Then we're looking at our current, like whatever the current threshold is that we just created, and what's the distance of our current AWR snap. In fact, I should actually put current AWR snap distance. And if the current distance is beyond the threshold, we've detected an anomaly, and we're going to print some stuff out, and we're going to print a little 2D chart so we can actually, see a picture as well, which is always kind of fun. And then quick alert the DBAs or anybody but yourself. All right, so that's the strategy right there. So these are all built on various functions up above. So just real quick, the first thing we're going to do, we're going to pick the type of cluster. And I've included 2 different cluster types in this notebook. One is called k-means, and the other is called mini batch k-means. Okay, mini batch is when you have a whole lot of data. K-means is when you don't. It's the same basic algorithm though, just a little different. The other, and got some settings, and then we're actually going to load data. The data that I'm going to use is sysmetric data. Sysmetric data rocks because it's already like per second, right? Average active seconds, average active sessions, which is like per second. How many IOs per second? It's already per second, which is perfect for what we need to do. I don't reference ASH data. I do that in my LVC, one of our last sessions. ASH data is like the best of the best data for machine learning for Oracle. I mean, sysmetric rocks, but if you add to that ASH, because then we have information about modules and actions, SQL IDs, and machine learning just gobbles all that stuff up and just takes that into account. But we're not going to use that today because there's some additional processing to get ASH data in the proper format. So we're going to load some sysmetric data. We're actually going to load some snapshot data as well. The only reason we need snapshot data in this particular program for this notebook is so when we print the chart, I want to actually have an actual snap ID with the associated date and time. Okay, the date and time in sysmetric is not always when the snapshot started or end. Okay, it's just when the data was gathered for, let's say, that row in sysmetric, whatever. Okay, so that's why I'm using both of these. Okay, now I have already downloaded the data, and so this is a CSV file right here, and I actually have that like on my laptop here. But you can also get it from this URL right here. It's sitting out there for you. So all you have to do in Python is just like uncomment that and use that. And Python knows, it knows. If you give it an HTTP address, it's going to go look for it. It's going to see if it's there. And if it's not, if it's just like CSV, then it's going to go in its default directory, or unless you changed it. It's so cool. So since I've uncommented them both, it's going to go for the most recent, and it's going to load the data from here. Okay, so I've actually gave you the URL for both of these. I'll comment that out just for the, but you don't really need to. Okay, so let's go to the top and let's go through this. I'm going to show you how some of this works, and I'm going to evaluate each cell. Okay, so the evaluation, this is real common on notebooks. You do a shift enter. So I'm going to do shift enter. Now testing equals true, you'll see in the functions that if testing is true, I'm actually going to test the function. So I have like the debugging built in at the function level. So it's a great way to teach people about machine learning. That's why I just love the notebooks. Okay, we're going to load some of the libraries that we actually need. And instead of doing the shift enter, we can also do this right here, and that's going to run the cell. If you hit the little fast forward, it will run all of the cells, all of them, until something bombs out or it finishes. So I can actually click run here. I'm highlighting the cell. I'm going to click this, and boom, it's loading the libraries, and then done. I got a print at the bottom right here. Okay. By the way, so this is print is just like print, right? Surprise. Here are some settings. I don't need to talk about, you do need, if you're going to run this, you need to set your default directory, right? So you've got to set that as appropriate. That's where like your CSV files are going to be. We're also going to create some PNG files of the charts where we've detected anomalies, and there's going to need to be a subdirectory off of kind of your home directory right here, and it's gonna have to be called pypix, and then it's going to be k-means for one of them, and you need to have another directory of the of the mini batch k-means. Okay, this is just like, you know, the name of the model. So make sure you have these created, otherwise it's not going to work. How about that? Okay, all right, so I'm going to evaluate these. Shift enter, boom, really quick. Yeah, make sure these are created. I recently added that, so because it was really, people are having a hard time with stuff. They didn't know what they needed to change and all that. Okay, load the data is super easy. You know, here's the Python right there. Okay, so there's a couple things to say about this if you're new to Python. Okay, PD. Okay, that's short for a library. I'm going to scroll up, called pandas. And so we're actually, instead of typing pandas, we're going to call PD. Okay, there's the two main libraries you need to know about just in Python are called NumPy and pandas. NumPy, which is what I call, I don't know if that's the official name, but it's numeric Python. All the heavy number crunching, array processing, matrices, all the machine learning stuff actually uses NumPy. Okay, that's the heavy duty math stuff. Okay. Pandas, I don't know what that stands for other than the animal. Pandas is where we do all the data frame activity. Okay, now as DBAs, a data frame is like a table. It literally has rows and columns, okay, and the columns have names. So as you learn about Python, and specifically as you start doing more machine learning, you will quickly notice that as a DBA, you are much more comfortable dealing with data frames than arrays. Okay, arrays just seem clunky. There's different syntax you got to be aware of. You got to be really careful. But with pandas, when you deal with data frames, you use the name of the column. And by the way, in machine learning, we don't use the word table, we use data frame, and we don't use the word column, we use the word feature or a label, right? That's that label if we're using supervised learning. So sometimes you'll see me down in here, right? I'll mention feature, but it's the same thing as a column, okay? All right, so we got some core settings here. We're gonna have to run those. Oh, I already did that, didn't I? You can rerun a cell, no problem usually. So I'm going to load some data, and then if we're testing, so I'm going to use the pandas library. I'm going to read the CSV file. and that's the name of the file that was put in right here. Now this could be the URL. This could actually be like the CSV file on your box, whatever. And we're going to take the results of this, and it's going to be put into a variable that I call it data df. Now I know the results of this because it's Panda. It will be a data frame. So to help me know it's a data frame and not an array, I usually put a capital DF. Now, I don't know other people that do that, but it works really good for me because I get confused. Is it an array? Is it a data frame? So I actually name the objects to help me out, okay? Real common is to get the shape, right? The shape of an object. It could be an array or it could be a data frame right here. The shape is going to be the number of rows and columns. So I'm going to evaluate this. So we are going to be testing. So it's going to first, since we're evaluating the cell, this function will be defined. We're going to create the function, and then we're actually going to run it. We're going to call it right here, load data. That's the name of the function. Okay, and then that's our testing. You know, that's the CSV file right here. And then I'm going to say, hey, give me the shape of the data frame because that's what's returned. Right, that's what's returned. And then guess what this is going to do, right? The first 4 lines. Okay. Yep. All right, so I'm going to evaluate that. And what the heck? Somebody's calling me. Get out of here. All right, so I'm testing the function. That's the data I'm loading. Here's the shape right here. That's the number of rows. That's the number of columns. Okay, so that's the shape. I use the shape all the time to make sure I haven't messed up with the data frame or the array, because like if this changes for some reason now as I go down, I'm going to need to know why. Okay, and I did a head 4, and so you can see there's actually the first 4 rows, and it just kind of wraps here. So you probably recognize some of this. Okay, so we've loaded the data. I'm going to do some cleanup. So I'm going to, by the way, I'm going to go faster as we go down here. I'm going to skip some stuff, but I wanted to make sure you kind of got some core stuff in your head here. So we're going to clean up the features, which is the columns. So what I'm going to do is we're going to get rid of any spaces. And if there's a single quote anywhere, I'm going to get rid of that as well. Okay. And we're going to test this. So we're going to create this function. Then I'm actually going to call it down here. So what I'm going to do, I'm going to give it that data frame that I created up above here. I'm going to use that data frame that I used up above. All right, so I'm going to give it that data frame, actually a copy of it, and I'm going to say, hey, this column, this feature called metric name, that's what we're going to get rid of the spacing and all that kind of stuff. And I guess I'm not going to lowercase it right now, or I just didn't do it. So let's evaluate this, and you can see this is what the metrics are before I do any changes to it. And now you can see here, I just got rid of the spaces right here. Okay, you can have spaces in your column names, but doesn't that just feel wrong? Yeah, it does to me. So I get rid of them. Okay, you could put underscores, but then they get really long. So that's just what I do. Usually I just lowercase it all. So, okay, so now we're going to load. I got a function to load and to clean up our snapshot data. Okay, and so I'm not going to go through all of this, but I do need to evaluate to create it. And then there is a test right here, and it's going to call our snapshot data. Okay, and it just did it. There we go. By the way, what I did is once I loaded all the snapshot data, I didn't want all the columns, all the features. I only wanted the snap ID, the begin time, and the end time. And so what I did, I said, hey, these are just the features I actually really need. Just forget the rest of them. And so I created, what I did, I took my existing data frame that I loaded the snap data in, and I said, hey, this is the feature list that I want for the data frame. So this essentially just gets rid of the other columns. It's like drop the columns, delete the columns. Okay, and that's why at the end here, I just have 3 columns for my snap data as I carry this down forward. Okay, we need to denormalize. Or no, actually, yeah, see, I'm so my mind has been just melted with this stuff. for years, right, we've been trained to normalize, normalize, normalize. First normal, second normal, third normal, whatever. I taught people, I breathed, I lived, I believe in this. In machine learning, you got to chuck it all. Okay. Machine learning expects for like a given like AWR snap ID, all of the attributes to be on one long row, right? So, and as I evaluate this, you can see, okay, this is, I didn't do the before, but you can see, here's the before. We have all these rows and we have 3 columns. And the column is like, you know, snap ID, metric name, you know, that kind of thing. But we pivoted or we denormalized it. And now we only have 210 rows. But now look at all the columns. See now all our metrics are now columns right here. But you'll notice each row is 1 snap ID now. And that's the way we need it for machine learning. Okay. So we have to denormalize, we have to pivot. And I actually created a function to do that with a little more detail in it. But you can see there's the underlining, there's a pivot function we're calling right here in Python. It does it amazingly quick right here. Okay, so that's a little weird. Okay, but you'd be amazed. Okay, there's 162 because this is rows and columns, and you can literally have thousands of these. Not that that's useful or you develop a great model with that, but you can have that. So if you think about Google and Facebook and companies like that, you are like the snap ID. Okay, all these attributes are things they know about you. And I guarantee you there's more than 162 features about you that they know. All right, so that kind of maybe is another way of looking at it. All right, we need to reduce the dimensionality. Okay, when we have 162 features right here, we are operating, get this, okay, this is cool. We're operating in 162 dimensional space. Whoa. We're like floating in 162 dimensions right here. Yeah, that's great for vector analysis and machine learning, but if we want to plot a chart in 2 dimensions, we got to go from 162, whatever that is, dimensions to like X and Y. And there's actually math that does that, and it's fast. So that's what this is all about. I'm not going to get into the details, but it did it. And so what happens is when we do this dimensionality reduction, we go from numbers that kind of make sense to us, like this, to numbers that are like, what the heck is this? That's because I went to 3 dimensions, X, Y, and Z. Think of it like that. Okay, super cool. All right, another thing we need to do, usually it's helpful to do what's called standardize our data. Okay, and there's 2 pieces to that. There's called centering and scaling right here. And usually our models perform better. And especially with clusters, it seems to make a big difference. Okay, so I'm not going to get into how that's done, but that needs to be done right here. And so you can actually see here, like an average active sessions, look at the mean, all of our like 210 snaps. We have 210 average active session samples. The average is 4.2, but after we've centered it, look at the mean now. That's basically 0 because it's e to the minus 17 right here. And then look at the standard deviation right now. It's 1.0 basically, whereas before it was like 6.8. Okay, so we centered it and we scaled it. All right, next we have to create clusters. Now I'm not going to talk about in Python how we actually do the modeling, initialize, fit it, predict. That's out of scope for today. But I did this so you can pick between one of 2 models right here. So we're going to create the cluster. We need to tell it, well, how many clusters do we want? And so we're always going to want 1 cluster because we're doing a single cluster model. Okay. So again, we're going to test it, and I'm going to test both of these, and I'm just going to do that. Hopefully everything works, and that just tells me that things actually works. Okay, I know, real exciting, but we just did actually create a one cluster model, and we tested it. It looks pretty good. Now this is really important for what we're doing here. And then this is some tricky math that's going on here. We need to figure out the distance from the center of the cluster. Like if we have one cluster, so there's one center to our latest AWR snap ID, that kind of thing. So what's the distance? Do that. Well, okay, you're thinking, well, Craig, what's the big deal? I mean, it's just like, you know, X, Y, and you figure it out. I'm like, no. You're thinking like 2 dimensions here. Actually, 2 dimensions, well, whatever. Our data is in 162 dimensions. How do you figure out the distance from here to here in like 162 dimensional space? Tricky problem, huh? Well, guess what? There's actually linear algebra with this normalization function that can actually do that stuff. We just say, hey, this is my data point that I'm looking at, the specific data point, and this is the center of my cluster. Do this linear algebra normalization, and it actually comes up with a distance, like a real number. Super cool stuff. So we're just going to calculate the distance for each one of my points. And then here's how I determine the threshold, right? We got our threshold we have to determine. What I'm going to do, I'm going to look at all of the distances for all, like there's going to be 210 distances in the data we're looking at, because we have 210 snap IDs, okay? It's going to look at all of those. Or I'll just say however many points in our cluster, it's going to look at all those points, all the distances. And then we're going to just take the 98th percentile. So what that means is if we have 100 data points, 2 of them are going to be deemed anomalous. Okay. Now, that doesn't mean the alert's going to go off, because remember, not only does the point have to be anomalous, it needs to be the most recent AWR snap ID. See, if I go back, this is what most people forget. They think, well, it means I'm going to have like alerts all the time. No. Because once we do the threshold, like these are all the anomalous points out here. All we care about is if the most recent AWR snap is the anomalous point. It's one of the anomalous points. Okay. All right. So that's how I determine the threshold. Yes, there's more elaborate ways to do this, but man, it's weird how well that actually works. Okay. So let's just evaluate that. Yeah, there's a lot to be said, but we won't get into that. I need the begin and end times for a snap ID in a format that's like humanly acceptable. So that is. And this is actually going to create the chart, because if there's an anomaly that's detected, I want to create a 2-dimensional chart. And that's what this is all about. And the chart is actually saved. Remember, I had you create those directories, those pypic directories, / the cluster type, like k-means, / the snap ID.png. And this will then create a PNG file in Python. So all you got to do, put a .jpeg, and you're going to get a JPEG file. Makes sense, right? And then this will actually save it, but we're also going to display that as well. Okay. All right. So I'm just going to create a couple charts. This is just testing it. That's what it's going to look like. So just so you know, these are all of our points that we made up our cluster. The green dot, that's the center of the cluster. And the most recent snap is the like big magenta point. So right here, you'd say, is that anomalous? Well, probably not. It looks like it's within the data right there. Okay. All right. So now we're ready to actually run this thing. So we've been talking for like an hour here, and we lost a few folks. You guys are hardcore. How many do we have? We got 26. So now let's actually roll. So we're going to set our cluster type. Do we want to standardize true or false? I put that there so you can flip it on or off just to see what happens. We need to do our core settings, and we're going to load our sysmetric data. Then we're going to load the snapshot data. And then I don't want to get into this, but how many points are we going to create our initial snap? or I totally wrong what I said. We want to, how many points we want to have in our initial cluster. Okay, I'm going to start with just 5. And then what we're going to do, the most recent, like that 5th point, that's going to be deemed the most recent AWR snap. So that's the one we want to check if it's anomalous. So we're basically going to go in a big loop here. We're going to start with a cluster of 5. Where's the 5th point? Is that anomalous? If so, beep, beep, beep. We're going to loop back again. Remember, this isn't live. This already have all the data. I'm kind of starting small here. You wouldn't do this in deployment because you're always, it's basically deployment. There is no loop, right? You just say, create a cluster with all the data that I have. Where's the most recent point? Is it anomalous? Okay, but in this case, when we loop through again, now we're going to have 6 data points in our cluster. So where's the 6th data point? The most recent? Is it, I found it? Is it anomalous? Is it outside of our threshold? And we're going to loop through again. Now we'll have a cluster of 7 points. Okay, where's the 7th point? I find it. What's the distance? Is it anomalous? No, we're good. And we'll keep looping until we get to like 50 points. Okay, so that's what we're going to do here, right? So we build the cluster. Okay. We're actually going to do that center and scaling right here. And then I'm actually, this is the create cluster function that we talked about. So we're going to build the cluster. Okay. Then we're going to get the threshold. So I am actually going to get a return the distances of all of the points in my cluster. And I'm also going to return the threshold. Okay. And so look at, so the current AWR snap, its distance, I'm just using a tail function right here. I'm sure there's a really more array cool way to do this, but tail works really good. Okay, so that's my ending point, the most recent. So that's the current distance, and of course the threshold as well. And then I say, okay, hey, is the current distance greater than the current threshold? Because remember that threshold will change as the number of points change. So it's always changing. And if this is true, then we found an anomaly. Let's print it. All right, so let's actually evaluate this. Oh, and what I wanted to do is there's on my, let me move the questions over here. I know you can't see that little box, but there's one there. So on my laptop, there's my k-means directory. You'll see as this runs, if there's any anomalies detected, the PNG files will show up right here. Okay, here we go. And it's doing all this stuff. It's loading the data, denormalizing, cleaning, all that. Now it's actually starting to do this. So I'm building a cluster from this snap ID to that snap ID. Okay, and it says anomalies not detected for the snap ID. So why? Well, its distance was 11 and the threshold is 13. So it's like, it's all good. But look at this one right here. Okay, for 7. It's saying, hey, Craig, wait a second, man. The distance is 20. That must be the distance here. But the threshold is just a little bit less than, oh, it would have been cool if I actually drew the distance. But anyway, the threshold is pretty close, but this exceeded it, therefore it's deemed anomalous. Okay. Now you'll notice, you know, it's gonna, as we get more points, this is gonna make more sense, right? So yeah, because we're kind of building this thing up here. You can see more and more points, but you can see usually, you know, while there are anomalous points, like that might be anomalous, this is the point that's the most recent snapshot. So then it is deemed anomalous. Okay, so you can see how fast this thing just goes, boom, boom, boom. And I only did up to 50. Oh, it didn't print in my directory. What's my directory? I have a couple different directories. Let me just real quick check. See, this is what can happen here. Oh, it's in testing. Craig. There's the testing directory, subdirectory. There's probably a bunch of stuff in k-means. Yeah. So like if I just, and that, we're gonna end right here. I'm gonna rerun this thing. So you can see that it actually does create the pics. You know, so I'm going to rerun the anomaly detection right here. Let me scroll back up here. I'm going to rerun this, and as it finds some anomalous activity, we will see, there we go. There's one of them right there. It's still running. There we go. Oh, found another one. You can see them all right here. And so these are the actual points right here. So now you have something to actually show somebody. Super exciting, I know. Okay, so that's it. That is a real anomaly detection system specifically for Oracle systems. All right, now what can you put that into deployment as is? No, you're gonna have to tweak it a little bit, but all the core stuff is actually there to get you going. And can it be more elaborate? Oh, heck yeah, for sure. Okay, all right, so if you're stoked about this stuff, become a paid AuraPub member. Check out my LVCs. And of course, the one that's about this is the machine learning for Oracle professionals. I'm actually going to break that up into multiple LVCs, I think, in 2021. But if you're even remotely interested in this, make sure you do this. Do the e-course. Okay, you're going to be stoked because it's going to get you started. It's all in Python too, so it's really simple. It's all text. There's no notebooks involved. Super simple. Okay. All right. I know this is being recorded. You can watch the recording. You can download the slides. I'm going to put those on my website tonight. And from my website, you can also download this notebook as well. And I think I actually show you how to install it here somewhere. Oh, okay. I'll put something on here. You got to install like a sandbox, your machine learning sandbox. I'm surprised I didn't put that in here. Which is the first session in the e-course, actually tells you how to get your machine learning kind of sandbox ready to go, which will be ready for this thing. Anyways, okay, that's it. We are done. Hey, thank you guys for being here. I hope it was useful and you got a little taste of how you can use machine learning in the IT sphere.
Thank you so much, Craig, and thank you, Coleman, for co-hosting this with us today. Craig, I'll probably ping you and get all the information everyone needs to make sure everyone has it in their inbox later today, so don't worry. We've also got Craig coming back to present for us again, I think in like 2 weeks.
Yeah.
So definitely register for that if you haven't already. And then for other Viscosity North America events, webinars, workshops, you can visit viscosityna.com/event. Craig's next presentation is posted there as well. But otherwise, thank you all for hanging in there with us. Thank you, Craig, for getting all of this information out to everyone. It's great. It's great content, and I can't encourage you all enough to take advantage of the time you have with these presenters we offer you. So I hope everyone has a great day and look for a follow-up email from me or someone on my team. And we'll see you then. Thanks.
All right. Thanks, guys. Thanks, Monica.
No problem. Thanks. Bye.